To fly. That's what it's all about. And that's what it's like when you fly in ultralight. But like any other form of flight, it can be dangerous. Although Federal Aviation Regulation Part 103 regulates the operations of ultralights, it has no requirements governing the maintenance of these vehicles. The purpose of this video is to make you aware of the more important safety aspects of ultralight operation. Some of these are: always conduct a thorough pre-flight inspection. Never combine the pre-flight inspection with the assembly of the vehicle. Perform frequent preventative maintenance using the manufacturer's recommended instructions and procedures. And make sure you are familiar with Part 103. And here to tell you more about ultralight safety is Mr. Wally Bevins, Supervisory Airworthiness Specialist with the FAA. And please, listen carefully.
Hi, today I'd like to talk to you about pre-flight and preventative maintenance of your ultralight aircraft. There have been accidents in the past that have been caused by inadequate pre-flight and preventative maintenance. So today what I'd like to do is I'd like to walk you through a pre-flight of an ultralight aircraft in hopes that we can point out these specific areas that have been known to cause accidents so that maybe we can prevent accidents from occurring in the future. But first what I'd like to talk about is what constitutes an ultralight. The rules governing ultralight operations are found in Federal Aviation Regulation 103. There are 6 conditions that must be met before you can operate your ultralight under these rules. These 6 conditions that must be met are: 1. It is used or intended to be used for manned operation in the air by a single occupant. 2. It is used or intended to be used for recreation or sport purposes only. 3. Does not have any U.S. or foreign airworthiness certificate. 4. If unpowered, weighs less than 155 pounds, or if powered, weighs less than 254 pounds empty weight, excluding floats and safety devices which are intended for deployment in a potentially catastrophic situation. 5. Has a fuel capacity not exceeding 5 U.S. gallons. 6. Is not capable of more than 55 knots calibrated airspeed of full power in level flight, and has a power-off stall speed which does not exceed 24 knots calibrated airspeed. Before we begin our pre-flight inspection, I'd like to bring to your attention a couple items. One of them is always use a checklist before you perform your pre-flight inspection. This checklist can be one that the manufacturer supplies with your ultralight vehicle, or this could be one that you designed yourself, taking into consideration everything that needs to be looked at on the aircraft. You should always use a checklist every time before you go flying to make sure that we've covered all these items. The next item I'd like to bring to your attention is if you store your ultralight aircraft at your house and you bring it to the airport and assemble it, before you go flying, do not make this your pre-flight inspection. Your assembly inspection and pre-flight inspection should be separate. So now let's get to our pre-flight inspection. The first item we're going to look at is the attach points, and we'll look at the wings. We want to make sure that the wings, the forward attach points, we have bolts, that they're secure. If we are using pins on our ultralight aircraft, we want to make sure that we have the clips and everything. This ultralight has aircraft-grade hardware on here, so it looks fine. Next, we're going to go around and check the rear wing attach points for security. We want to take a look at our rear wing attach points. We want to make sure that we do have them safetied and that those are secure. They're not loose. And in this instance, we've used aircraft-grade hardware. If you were to have the old style that the pins came through, we would make sure that you would have your clips safetied at this point. Now let's go to the tail section and look at that for security. We're going to come back here and check the horizontal stabilizer. We're going to check the attach points. In this case, there's 4 attach points. We want to make sure that the hardware is on there. It is secure. Grab the horizontal stabilizer, give it a shake, make sure that these are not loose, that these are indeed tight. As we move from the horizontal stabilizer back here to the elevator attach points, we notice on this particular application we have a pin in here that holds this, along with the new style clip. The old style clips that were very conducive to coming open and these pins falling out, that has been the cause of numerous accidents. So if you have not changed these on your aircraft, change over to these new style clips. Also, if you notice right here, this application has been lubricated. A lot of times what happens is that when this becomes dry and rusted, you can check it. It'll have a lot of play in it. It wears out this hinge right here. When this hinge wears out, it sets up a vibration in your elevator and could produce flutter. As we move down the elevator, we want to check the rest of the attach points for the same thing. Make sure they're lubricated. Make sure that they have the safety pins. The next item we're going to look at is the rudder. We'll come right to the top of the rudder and check that attach point. Again, we want to shake the rudder, make sure that there is no play in it. This is using aircraft grade hardware up here, but as we move down, we notice the pin in the safety clip is safety. Same thing with the bottom one. We want to check both ailerons for security. We want to make sure that the pins are indeed in and the safety clips are on. We also want to check to make sure that it's been lubricated and that there isn't any play in the aileron itself. As you notice right here, this pin and safety clip have been installed, and at this point they're not using aircraft grade hardware, so this looks good. Now we'll move on to the fuselage and wing covering to see if we can find any problems there. The first thing we want to do when we're checking fabric is we want to check for obvious signs of deterioration like rips or tears or broken threads. This aircraft has been very fortunate in its lifetime to have spent most time in a hangar where it has not been subject to the deterioration of the ultraviolet rays, which brings to mind a couple accidents that have resulted because of the deterioration through the ultraviolet rays. We had an aircraft that was stored outside for quite a long period of time, and as it rained, this fabric deteriorated to a point that it allowed it to absorb water. Well, underneath here, the fabric is still good, and it trapped the water in there. As the aircraft went to take off, the left wing went low, and the aircraft crashed, fatally injuring the occupant. The second accident that occurred due to the deterioration of the ultraviolet rays happened when this gentleman was flying his ultralight, and he had a small tear in the upper wing. As the air got up underneath that tear, it ended up ripping back that fabric and causing that aircraft to nose over, also fatally injuring that person. So we want to make sure that if we store our aircraft outside, that we put some kind of covers on it or check for the deterioration of the fabric itself. I have several examples of unapproved repairs that have been made to the fabric. If you'll notice on the first unapproved repair, we have a picture of an ultralight that had a hole punctured in the fabric. If you notice, the owner had threaded a tie wrap through there and pulled a type to keep it from ripping any further. This would not be an acceptable repair. You could still get air down inside the wing, and it could still probably rip this fabric a lot further. Let's take a look at the second example I have. Notice how the owner had put silicone over this tear in hopes to keep it from tearing any further. This silicone would not bring this fabric back to its original strength, and therefore would not be an acceptable repair. As we move to the next example, notice the stitching, how this was stitched to keep it from tearing any further. This would be considered a good repair. If you'll notice in the last example that I have that was taken out of Advisory Circular 43131A, these are samples of different types of stitches that you could do if you were to come across with a tear in your fabric that could be used as an acceptable repair. Always remember to use your manufacturer's suggested instructions for repair of fabric. If there are none available through your manufacturer, you could always refer back to FAA Advisory Circular 4313 for acceptable repair procedures. Here we want to look at the propeller and the reduction belts and the bearings. When we're looking at the belts, we want to look for overall tightness, security, and deterioration in these belts. Actually, the only way that you could check these belts would be to pull the propeller off and turn them inside out and check them. However, you can look for cracks and stuff or any indication that there's been some slippage. When we look at our bearings right here, we want to make sure that we grease these and keep grease in them, because if these freeze up, we're going to lose our thrust on our propeller. One of the problems we've also had, and we had an accident that was caused by over-tightening these belts, which puts a great strain on this bearing. So you want to make sure that the belts are whatever the manufacturer suggested as far as tightness. Okay, we'd like to look at the propeller. What we want to check on the propeller is we want to check for security. We want to check and make sure that the bolts and everything are nice and tight and safety if it requires it. These right here these mount bolts are using aircraft grade hardware with locking nuts. Some of them require that these nuts and stuff be safety, and we'll give an example of that later. As you look at the propeller, bring your hands down the leading edge of the blade, look for nicks and cuts. Nicks and cuts that could produce cracks and end up losing a piece of this blade, which would ultimately shake this whole bearing section loose. So we want to make sure if we do find nicks and cuts, we want to go back to what the manufacturer says on how to repair them. If the manufacturer does not give you any instructions for repair of propellers, then back to Advisory Circular 4313, which will give some instructions on how to repair propeller blades. A very important item, if you have a wooden propeller and you install it, you should go back and retorque it after the first 25 hours after installation. If you also live in an area to where it's very conducive to moisture, you want to go back periodically and retorque your propellers. The reason being, as moisture enters through these holes, it causes the wood to swell, which tightens up on the bolts. As it heats back up and it contracts, it will literally make your prop bolts loose. So go back every 25 to 50 hours and retorque your prop bolts, especially if you live in an area that's high humidity. Here we move to checking the fuel and the engine. The first thing we want to do in this pre-flight when we check the fuel is to turn it on. So we want to turn on our fuel. You would not believe the number of accidents that have been caused by fuel starvation or fuel exhaustion. People not turning the fuel on or simply not having any fuel in the tank. So after we turn it on, we make sure we have fuel in the tank. And also we want to talk about these fuel lines. If they're not pliable, they've gotten hard and they've yellowed like this, you might think about replacing these lines so that they don't crack in flight and you have fuel spilling all over you. As we move to the engine, we'd like to check the engine mounts. We want to check for security. Make sure the bolts are up in there. Make sure the engine mounts haven't cracked. And if your engine has a lot of oil all over it and the oil has soaked these mounts, you might want to think about replacing them. Again, we check fuel lines. Let me flash over to an example of a unacceptable way of securing these fuel lines would be with safety wire. As you can see in this example, these lines have been safety. What happens is that safety wire cuts into that plastic tubing and it can start sucking air. This example of this engine does not have a fuel bulb. If you have a fuel bulb on your ultralight, you would want to bend it as it is in this example and make sure that there are no cracks to where air could get in and cause fuel starvation. Another item is our air cleaner. We want to check our air cleaner and make sure it's secured good, make sure it's not dirty, and if you go to buy a replacement air cleaner, you want to make sure that you stay with the manufacturer's recommended cleaner and not go to a paper one that can ingest water and moisture and stuff. Other items we want to check for is we want to check for throttle operation to make sure that our throttle is operating and throwing fully. We want to check for choke operation. Again, we want to make sure that we can lubricate these and that they stay lubricated so they don't give us any problems. Overall, we want to check the general security of the muffler system, make sure that the shock mounts are in good shape on it, make sure that all the clamps and everything are secured. Okay, we want to move right along to control movement. We want to make sure that our controls correspond with the direction that they're traveling to make sure that we haven't hooked them up backwards. So we check the rudder control, we check the aileron control, and the elevator control. From there, we want to check the control rods to make sure that there are no play in them and that they have been lubricated. In this case, we have aircraft grade hardware. We do have a little bit of movement, but that's not an excessive play. We're going to move there over to the aileron control rod. In this case, we check for security. We have a pin, we have the safety clip in it, and it has been lubricated, and there's not excessive play in there. From there, we go back to the elevator control rod where it attaches here. Again, check for security of the bolt. Make sure if you have a pin in there that the safety clip is on there and that there's no play. We had an accident that was caused by a gentleman that put together his aircraft at the airport. He reversed the aileron cables upon takeoff and everything. One wing dipped low, caught the ground, and he was fatally injured. So we're going to make sure that we have freedom of movement throughout all our control surfaces and that they are moving in the corresponding direction. Next item we want to take a look at is all the cables on the airplane. We want to come down here to where these cables are swedged. This has been a big problem area right here. Where these things are swedged usually will result in a lot of fraying and deterioration. We also want to check the attach points. Make sure our bolt and everything is nice and tight and there's no play in there. Also check on the back side for wear to make sure that the cables aren't wearing into them. Now the way we check cables, we'll come down here on the rudder cables, because we want to take a rag. We want to run the rag down the length of the cable. If there is a snag or anything, it would snag on this rag, and we want to do some further investigation. Usually you're going to have to take these cables loose and turn them upside down and bend them to see if there's been any more of the strands that are broken. In the way of cable maintenance, the worst thing on cables is rust. Moisture gets to these cables on the inside and they start rusting. So after you've checked your cables and they look good, what you want to do is put a good corrosive preventative compound on there to keep them from rusting. On cable maintenance, another one of the big problem areas is people will come down to where your cable passes through these pulleys. The only way that you can effectively check these is to take and move your rudder pedals, move the cable off the pulley. Also make sure that the pulleys are lubricated and are turning and they're not stiff. If they're stiff, the cable will usually rub in there and it'll start fraying. So our cables look real good on this aircraft. Normally a good visual inspection of the cables will determine any kind of fraying and any kind of problems that you would have. I want you to take a look at this example of a frayed cable. This cable was removed off of an aircraft. The cable had passed over a pulley, as we had talked about earlier. The only way we detected this was moving that cable back off the pulley, and we had to actually remove the cable off the aircraft, bend it inside out so that you could see the frayed portions. This cable ended up being replaced. Now, if you're going to replace cables, you need to replace it with whatever the manufacturer suggests. If you have one of the older style ultralights that have the pre-stretched nylon cables, do not replace these cables with clothesline. We had an accident that involved the replacement of cables with the pre-stretched nylon cable with clothesline, and when the guy got up in the air, the clothesline stretched too much. He was not able to control the ultralight and actually ended up killing himself because of this problem. So always use whatever the manufacturer suggests as far as cable replacement. The next item we're going to talk about is safety equipment. We want to check our seat belts. We want to check to make sure that they're not frayed. We want to check the attach points. Make sure that these lap belts do lock in place and that they're the overall condition. Now I want you to look at the example of some seat belts that are frayed. These have been caused by deterioration due to ultraviolet rays from sitting out in the open, and therefore these belts would not be in serviceable condition and would have to be replaced. The next item of safety equipment we want to talk about is we want to talk about your ballistic parachute. If you have one installed on your aircraft, make sure that you remove this pin. We had an accident that involved a gentleman that was flying, and he had a wing depart the scene. We don't know why. However, he had a ballistic parachute on, but he failed to remove this pin, and he was filmed on video trying to pull this thing all the way down. So even though this seems simple, make sure that you add this in your pre-flight that we're looking at this. Make sure you remove this pin. The next item would be your altimeters. If you have altimeters installed on your aircraft, make sure that you have them repaired by a FAA certificated repair station. Do not attempt to try to go in here to repair these things yourself, because these are very sensitive instruments and you need special test equipment to be able to repair them and test them. The last items that we would like to look at on a pre-flight inspection will be the overall general condition of the framework, the tires and brakes, to make sure that they're attached and that their bolts are secure. We want to make sure that our seat is secured and it's not loose. And overall condition of all the tubing to make sure that we find no cracks or no bends that shouldn't be there. Another thing on the tubing we want to look at is corrosion. If you live in a area that has very high humidity or salt water, it's very conducive to corrosion. As soon as you identify corrosion, you want to take care of it immediately. Now here's an example of what some corrosion looks like on the tubing of an ultralight. This may or may not have to be replaced. This concludes our pre-flight inspection. What I'd like to talk to you next about is what you can expect if you're approached by an FAA inspector and you're asked to prove that your ultralight meets the requirements of Federal Aviation Regulation Part 103. First of all, you will not normally see an FAA inspector unless you're involved in an accident or an incident. Upon initial contact, the FAA inspector will ask to see your pilot certificate, your medical, and your aircraft registration. At that time, you'll inform this inspector that you're operating under Federal Aviation Regulation Part 103. Federal Aviation Regulation Part 103.3 states in part that the administrator has the right to inspect your vehicle to make sure that it meets the requirements of this part. Also, 103.3 states that as the owner-operator of this vehicle, you have to provide satisfactory documentation that it meets the applicable section of this rule. What is satisfactory documentation? You may be asked by an inspector to show compliance with Federal Aviation Regulation 103.1 by measuring the fuel capacity of your ultralight, by weighing it or showing documentation that it was weighed, as we talked earlier, and certified by an airframe and power plant mechanic, or by measuring the wing, stabilizer, and control surface areas, or any other checks that we may deem necessary to determine that your vehicle meets the applicable requirements of Federal Aviation Regulation Part 103. So remember, as we've talked about today, do a good pre-flight, do your preventative maintenance, fly safe, and have some fun.
On behalf of the FAA, we'd like to thank Wally Bevan for volunteering his expertise for this video, and thank you for your time and attention. For more information, please contact your Flight Standards District Office.
Oh man, that was fantastic.